by now you've probably already gotten exposure to regular expressions from a practical perspective in text processing. We're going to start off today by just a minimal formal characterization to set the stage for the main content of today. So suppose we have a finite alphabet sigma, so this might be the ASCII characters or just the letters of English or something else, and we're going to say that a regular expression is any character sequence that is drawn from any of the elements of the alphabet and the star, the pipe for disjunction, and open and close parentheses. And so long as the result of the sequence of such characters has matching open and close parentheses, then it's a valid regular expression. So for example, if my alphabet is just the letters A and B, then any of the following things are valid regular expressions. There are many of them that you see here, but that's just the syntax of what a valid regular expression is. One more thing, the empty string is also a valid regular expression. The semantics of regular expressions are as follows. And we think of this as in terms of we're going to use regular expressions to match or to try to match against strings. And the strings any individual string will be a sequence of characters from the alphabet sigma. And the semantics of what the regular expression parts say is as follows. First of all, the empty string will match a 0-character sequence. Any individual character from the alphabet sigma will match an instance of that character in the string to be matched. The semantics of concatenation, so for example, this BAB regular expression is the concatenation of B with A with B. Concatenation has the semantics that if I concatenate expressions X and Y, then it will match anything that first involves an instance of X and second involves an instance of Y. That is, and an instance of means something that X matches, something that Y matches. X star means 0 or more repetitions of X, so it matches anything that contains 0 or more repetitions of X. The pipe is disjunction, so X pipe Y will match either whatever X matches or what Y matches. And the parentheses simply determine operator precedence. Concatenation generally has lower precedence than the pipe or the star. So if you want to have a star or pipe apply to more than one character at once, you use parentheses to make that clear. Now, that's the minimal formal machinery. In many regex implementations, which you probably are already familiar with, there's some additional machinery that's generally involved. So one thing to say is that in general, regex engines may allow you to do either partial or total matching requirements. So in Python's RE package, for example, search looks for a partial match. It looks for any substring of the string that you're trying to match that will match the regular expression that you give it, whereas full match requires a match to the entire regular expression. The formal properties we're going to be interested in and will focus on will basically be corresponding to full match. But just be aware of that actually the more common in practice usage is a partial match usage when you're actually using regular expressions in text processing. There are also a lot of conveniences that you see in regular expression implementations that don't change the formal power of regular expressions in terms of their expressivity, but make it more convenient for daily usage. For example, the character classes that you use with square brackets. So for example, open square brackets, A-F, close square brackets, is equivalent to this junction of A or B or C or D or E or F. And that's a convention. It doesn't change the formal power, but it makes it shorter to write the expressions. The anchor characters, which are useful in conjunction with partial matching to require certain in-string positions, like the beginning of the line for the caret or the end of the line for the $sign. There's the cleany plus, which is, for example, X plus has the semantics of X followed by X star. It matches, whereas X star will match 0 or more instances of something that X matches. X plus will match 1 or more repetitions of X. Another version of this is the counter. So for example, X curly brace M comma N, close curly brace says between m and n repetitions of x. And then the period is very well known as the wildcard character. It will match any symbol. It's a kind of character class. And many regex implementations have more wildcards as well, for example, for all alphanumeric characters. Once again, from a formal language point of view, none of these change the expressivity of regular expressions. You'll also, in implementations, find some things that affect the regex engine's matcher. So, for example, look ahead and look behind, or kinds of this. And there's one thing that you find in regular expression implementations generally that actually takes you beyond the standard formal flexibility of regular expressions as this string, this sort of way of describing strings, which is back references. So you may be familiar with the usage of if I have parentheses x, close parentheses, now the usage of the parentheses gets an additional function, which is it captures whatever is inside x, and it remembers it, and then you can compute on that. So open x parentheses x, close parentheses y, and then \1 would say this. The \1 says look for the first group that precedes, so the first group in the sequence, and then this will have the semantics of I match anything that x matches, followed by anything that y matches, and then another exact string replica of whatever x matched. So for example, this regular expression using back references, AB in square braces star in parentheses B/1 would match B, it would match ABA, BBB, ABBBA, but for example, it would not match ABB because ABB would have, although B would be in the middle, A would match this regular expression right here. B would also match it, but it's not matched in the same way in the two uses, and so that would be a case that this does not match. And actually, matching regular expressions, as long as when they have arbitrary back references, is actually NP complete. Whereas we're going to find out that regular expressions without back references are actually much more straightforward to deal with. So a lot of the complexity of modern regex implementations actually winds up deriving from this property of back references. So that's regular expressions in a nutshell.